All right, let's get started. Since I can figure out how to start this. There we go. Okay, last time we were doing sort of what I call sort of like the ObjectiveC Bootcamp, just going through, hitting it. We just went through maybe first part. Oh yes, good, 24. My TA has told me to slide 24. I actually don't have a TA for this class, but all right. Let's see. So it's kind of weird to start in the middle of the lecture. However, just to review a little bit, get us up to speed, ease us into the concepts here. We were talking about objects and the implementation of them in terms of Objective-C. We were looking at the NS object, which is the root object, and then if we're going to build GUIs, we're going to come from MS Application and MS Document and MS Everything. Everything is NS, excuse me, not M. N is in Nancy, S is in Sam. For next step, actually, is what that stands for, which was the operating system that this was originally built for, before it turned into OS X. And we know that OS X, the current version, I believe, brought us to Objective-C 2.0, which was the OS X version of the original Apple operating system. Anyway, long story short, we covered instance variables, and we covered methods, and we covered overloading and overwriting, and we looked at the syntax for creating objects using alloc and init, and the concept of making an ID as a generic reference to an object, and then this is referring to an object, creating the reference my rectangle x, and then this is assigning my rectangle. Well, this is interesting. Why does it have an X there? It should be just say my rectangle equals. There's a typo in the slide. Didn't even notice that until now. Rectangle alloc, which means allocate a new rectangle, and then run the init on it to initialize it. We looked at the structure of the class files with the .h file and the .m. So we have the implementation, and then we have the interface that goes along with it. And we looked at the directive. This is actually called a directive. It's called the @ directive. And the @ directive gives us things for definitions of strings and objects. And it also tells us that this is an interface, and this is the end of the interface in this particular syntax. We have one that says @implementation. And then it also is followed by an @end at the end. This is basically giving us the definition of the class, and we also looked at it last time that we put the variables inside of the interface, and then we have the method declarations outside of the opening and closing brackets that follow the interface, which is a little different than C++, is a little different than Java as well. In traditional other languages, we put everything inside of the opening and closing brackets, so this is a bit different in terms of the syntax. We looked at the concept of there being instance variables and those variables, and these are some, actually there's two different types of variables here. We have primitive variables, which are not objects, and then we have something like this that's called NSColor, just like NSString. Or NS something or other. Anything NS is an object. And if it's an object, it's a pointer variable. So we use this asterisk to say it's a pointer or referenced variable. These guys don't have pointers. They never need pointers. You have to get used to pointers because everything's an object. So you'll have to. And pointers, I have probably Monday I'll cover that lecture. I'm going to cover pointers again, along with memory. So I don't know if we're going to finish all of our Objective-C stuff today. It probably will carry over into Monday as well, but it'll be well worth it because then we can build more sophisticated apps after this, hopefully. I looked at the concept of the plus and the minus symbol being used in front of the method declarations, and that's indicating that one is an instance and the other one is a class method. Why do we need to do that? Well, because it gives us our focus or environment scope, however you want to describe it. It tells us where the stuff is visible. If we want it, the plus is going to be available to all instances of all of the objects in the main program. The minus is only visible inside of the instance, and what happens is instances of that particular class hold their own data, and they can run their own methods, and the methods that they're running are the ones with the minus signs next to them because they're from instances. We looked at the differences. Actually, I'm not even sure if I mentioned the differences between import and include. We can actually do both. Import will bring it in there, and basically import and include do the same thing. Basically, if you're going to use a third-party tool, library, you're going to create a class and you're going to include that class into main or something of that nature, you're going to import. In this particular example, if we were in main, we'd be importing rectangle.h. If we were going to do that, and I'll show you an example of that today, we could include it as well. If we included the linker from a statically compiled language perspective, which is C, statically compiled, include was used to link the code in for all the functionalities that we needed. Yeah. In Objective-C, we're dynamically allocated, so we import, which is sort of the same terminology that you get with Java and other languages, because what we're doing is we'll find it. If it's there, use it. If we don't need it, don't use it. Don't bring it in unless we have to bring it in, kind of thing. It's doing the same thing. It's doing a linking of the object, but it's doing it in a slightly different fashion. But it means the same thing. You can actually use it interchangeably in your Objective-C programs. 1 or 2% of the time, you might end up with a problem, though. So it's safer, depending upon what you're doing, it's safer to use the imports. So it reflects the fact that the class definition builds on the definition. So in this particular case, we're importing rectangle, .h inside of rectangle.m. And that's the import directive. Refers to other classes. Well, we can use the @class symbol if we're doing that. So we can say @class rectangle, circle, which means we're referring to another class that's not in our hierarchy. It's in a different hierarchy. So it must be declared with the directive. And so here's an example of it, where we have an import class name .h, and this is our implementation. This is our interface here, and our methods are going to be in here, and then we're going to have down here all of the code that's going to be associated with it. I don't particularly like this example. I'm going to show you a better one today. It's a little bit easier to understand. This one's kind of convoluted, actually, not very standard, so I'm going to skip through that. And I believe we also got this far as well. We covered the differences between GCC and Objective-C, noting that they're pretty much the same thing. Objective-C is compiled with a GCC GNU compiler. And just today I had a student ask me if they can compile on Windows. You can't really compile on Windows. You have to load a virtual machine on top of Windows and then install the compilation tools inside of the virtual machine. Because it runs, it's actually compatible with Ubuntu. Not compatible with Windows, though. It runs on a totally different architecture. Although there are some people out there who have played around with Windows compilers for this. The only problem is it doesn't support Xcode. It doesn't support any of the GUI either. So you can write really command line prompt programs with it if you want to. But you can't do any iPhone or anything else with it, iPad. Alright, so the Objective-C is layered on top of the C language, and then we have iPad, iPhone uses it as the native applications that are written in Objective-C, and the Apple Dev Kit for Objective-C is called Coca, as we've seen so far. So everything is called Coca. We have Coca Touch for the mobile devices. We have the Coca interface for the Foundation classes. It comes from Foundation, by the way, so when we compile on a command line prompt, we actually include the Foundation network, the foundation.h, actual foundation framework, which is just giving us our Coca definitions, essentially. And as another side note, I forgot to mention that ITU has subscribed, or is in the process of subscribing for Apple's University Development Program. So each of you, hopefully within the next couple weeks here, will get this before the end of this course. I'm hoping we're going to get this settled. And what it is I'm going to walk through, hopefully, how to, because you need to get a provisional, you have to download stuff, you have to register your device. There's a whole process you have to go through just to put the application on the phone. So if you have a phone or if you have an iPad, you'll be able to demo it. I'll announce it ahead of time as soon as we get those accounts created. It's just a generic university account. You can't put anything in the store with the account, but you can certainly use it to register your device as a student at ITU, essentially, and be able to load your programs onto your personal devices. It only works on one device per person, but that's all you need, really. So you can show off to your friends all the cool little programs you made. Actually, you can take that little adventure game we're working on in the other class, put it on there. I might do that myself, actually, but I have to change the wording around on it a little bit, so I'll put some graphics on there. But hopefully we're going to get to that point as soon as we get through this Objective-C and we have more skills that we can use. So, all right, we got this far, and we started talking about the file overview as well. Source code files with the .m, remember that? Header files with the .h extension. This is GCC. Here's the foundation. So I was talking about before. This is Hello World, and this is a foundation network. And what we're looking at is a main program, and the main program is doing an auto-release pull. And I'm going to show you this, and I'm going to show you a different Hello World in a few minutes to kind of show you what the difference between this this drain pool and no draining a pool, using an auto-release pool instead. So what you're looking at on the slide here is actually the old way of doing it before automatic reference counting came into place. What does that mean? Well, we created a pool, and the pool was a referenced object of auto-release pool type, and so we allocated it, we initialized it, which is you're just going to need to get used to that kind of format. Created that object, and then we printed something to the screen, and then we had to drain the pool to release the objects. That's a project that does not use automatic reference counting, because we have to allocate, and then we have to we have to drain. We have to release, retain, release, or drain the pool in terms of its characteristics. So let me show you what I'm talking about. Now when we create projects, I'm going to create a command line because I want to use NSObject. Actually, I'm going to see just something very similar to that example we just created, or we just looked at. And I'm going to go next, and I'm just going to type in test here. And I had auto reference counting selected. Actually, let's see. You want to select this auto reference counting here. And I'm just saving it to my desktop, which looks pretty full right now, looks like. I'm going to go ahead and open up main here. And I'm going to compare this and go, wow, a lot less code. What you're looking at is this right here is main now. With auto reference counting, we created an auto release pool with an opening and a closing bracket. That's all we did. That is all we have to do. There's no more retain, there's no more release, there's no more drain, there's no more allocate. We still have to allocate when we're going to create objects, but we don't have to deallocate. So automatic reference counting, basically when we're using alloc, it's sort of like using new, as I explained last time. We're allocating memory. Every time we allocate something, if we're not automatically releasing it, we have to manually release it. We use the word release to manually release it. We don't want to release it, we use retain, so we can keep it, right? So when we put auto reference counting in there, the system does it for us. So we can allocate all we want, we never have to deallocate anything, because the reference counting will keep track of how many references are to that memory, and when it becomes 0, it'll automatically remove it for us, which means we're not using it anymore. So it's a mechanism that was built into just the last version, actually, of the API that essentially, or the SDK I should say, that implemented that and changed, revolutionized everything. So this is a lot easier to show you, actually, than this slide set that's got it all written out in the long way, essentially. So in here we have, this is all of the code that is essentially equivalent to it, which is a lot more code. So I want to show you Hello World, and I want to show you where these examples are before I do that, so you can run them yourselves. They're coming from the ObjectiveC classes, you might wonder, you might expect. So if I click on this summer 2012, I go into ObjectiveC programming, and I go down to the bottom here, I'm going to see the source code examples. What I'm covering today is number 1 and number 2. Maybe I'll get to number 3. Now, these are all going to go through all of the different features of ObjectiveC to show you, basically everything you need to know, which is going to be enough for this particular class. I mean, we're not going to write Coca applications for the Mac, so we don't actually have to do that in this class. So, all right, so this is actually Hello World, but let me show you a different Hello World. And the Hello World I'm going to show you is going to be in the first lecture, the first file for lecture number 1. And it's a simple, and if I click on the M file out there, I can see this looks familiar. That looks like the one that was from the lecture. This actually still works. If I run this in Xcode, I'm not going to bother doing it, but if I run it in Xcode, I just deselect in Xcode. Oh, okay, I'll go back forward. Oops, wrong one. Let's take that down. In Xcode, if I can get Xcode up, here we go. Oh, it is up. Just close this one here. New project. Let's go command line. Let's take this off. And it's going to complain. I'm going to replace it. It's just garbage anyway. Oh, I took it off and it still didn't take it off unless I didn't save it. Anyway, it should have given me the non version of this. It should have given me the other one. I probably didn't. I probably clicked it too fast. Didn't take it off. But anyway, long story short, this is essentially the long version of it. In the lecture, there's a couple of other examples. This is the same one. Example number 2 uses, and I'm just going to show you the source code instead of going through it. Ignore all of because it's using, all of these examples are actually using the older method without the auto-reference counting. But we're just using a regular non-object-oriented program. It is written inside of an object-oriented language, which is kind of interesting. So it just goes to show you can still program like that. It's kind of like C++ that you can do. You can't do this in Java, but you can write non-object-oriented programs in ObjectiveC. And here's one right here. It's just main. There's just one file, and it's just an M file. There's no H to it because we're not really creating an object. We're just running a program. In fact, you'll find in the main projects that there is a main.m, but there is no main.h. Never, because you're not creating an object. This is the driver program, which is not object-oriented actually, which is interesting. But here we have a integer, and then we're going to have a final integer, and then we're going to print it to the screen. I believe I showed you the printf last time. Did I not? I'm pretty sure I did. You can use nslog. Nslog is the equivalent to printf, but nslog is the object-oriented version, and it's printing to the nslog. Well, the ns is the next step. The log is the command console, so it's printing it to the command screen. Very similar to this here. That would also work. Just in case I haven't shown this yet, I want to repeat it because it's worth looking at, only because then those people who have a little bit of C in them, a little C exposure, can feel comfortable, because if you can't remember nslog, you can always use printf. So now featuring. In fact, it's you know what? It's the same syntax. I'll just why? Oops. Okay. I gotta figure out how to copy and paste. And there we go. There we have it. So that would actually work the same fashion because it's the same syntax. And I believe I have these saved out here. And we can use a GCC compiler if you installed Xcode and selected the option for the command line tools. And you'll see that in the preferences. And there's a command that uses the framework. And what I've got here is let's see if this is actually in here. No such file drag. We removed the files. Let me see. Go back a little further. I just demoed this the other day. Yeah, here we go. I have a program called example1.m, and I just compiled it actually. If I bring it up here, example1.m is a simple program, very similar to what I just showed you a few minutes ago. It's another hello world program where we've got integer main, just like C. This is a very C-like way of programming actually. So we declare a function, a main, and our whole program is going to begin and end in this function. We have two parameters that are separated by a comma that are passing arguments. So we have here NSString, which is the string version of string class, string.h in C++. We have to use a pointer because it's a string object, and all the objects require pointers for their variable types. And this might look familiar. We're taking a TestString here that we just created, and these examples, by the way, are in those files I just showed you a few minutes ago, so you can download them and compile them yourself if you want. But here we're allocating a string, which means we're taking a string object and allocating it, and then we're initializing it, and then it's going to be equal to this test string. Well, that's all. We did nothing more than create the memory for this test string in this particular line of code. And then down here we're going to actually put the test string in there. So now that we have the memory allocated, this is, again, this is sort of like saying new string, and then test string is equal to, and then we're using this @ directive to say, you know, tell the compiler that this is going to be a string. It's a directive basically instructing the compiler to put this in the memory space for test string. So here's a string. Here's a string in test string, which is our string. And then down here on the bottom, we're just going NSLog test string. And then we're putting this test string in. In fact, in the last example, we used an I believe. In the, I still have it up. I think I do. Actually, no, this is the wrong screen. Yeah, do you have it up here? We used an I because this is an integer that we're printing. So students up here is integer I. It's actually really easy when it comes to objects because objects are always @ So we have the $@ here to say, because, and we're always using @ so we don't have to worry about what kind of object is this thing. Is it a string? Is it a person? Is it an employee? So it's always the @ symbol to print out test string. Well, test string is a string, so it'll be printed out, but we defined it here with this directive as well, which is kind of interesting. So anyway, so if I run this, I compiled it a few minutes ago by running GCC, so it tells you, well, it's compatible with C. Well, this is a GNU compiler, GNU setup, so we can run GCC, and then this -framework foundation is telling us to use the, include this package along with it, this information for the foundation, which is the Coca libraries, because we're using NSLog in this program. If we weren't using NS anything, we wouldn't have to include the foundation, actually. But then we would be writing a C program, if you think about it. And then the name of the file, which is ex1.m, and then the -o says this is an output file. Get the output name, call it ex1. So if I press return, it will actually create it for me. And then I can run the program, and you can try this out actually at home if you wanted to. And then we see that test string, this here is a test string and test string. It doesn't really do anything, it just prints out the string to the screen. But it kind of shows you can take and compile Objective-C with a GCC compiler on the command line. It's compatible. So people with Windows can load on Ubuntu on top of Windows and then run it with GCC. But you're not going to get Xcode, that's for sure. But you can run it this way if you want to. It works. You just can't do any iPhone development this way. It doesn't work. It doesn't work out that well. All right, so that was one of the examples. The other ones, I believe, hello. Yeah, I've already done hello. This one here, I'm going to wait and do. I'm going to do person instead of student. Actually, this merits a little bit of a discussion here. So I can put these side by side. We can take a look here. So now I have the definition of a student object. And here's my student.h file here. And I didn't put anything up here because I'm not really doing anything that needs any libraries in the .h. I'm not inheriting from anything. But this format is pretty cool because it's just basically showing us, the @interface student:_NSObject. And all of our classes are going to look like this. Our opening and our closing brackets for our data members that are associated with this class. So we have the number of undergrads and the number of postgrads. They're 2 integer values. And then we have, excuse me, our 3 functions, or methods. We have void print, we have set undergrads and set postgrads. And we use a colon because we have parameters here. And one of the parameters, well, the parameter is going to be an integer. So set undergrads is going to take an integer value when we run it. And it's going to print out, well, it's going to set the value for it. We're not using properties, and we're not using synthesize in this example. The next one I'm going to show you is going to have properties and synthesize in it, which is the more common way of doing it. But this kind of helps you kind of understand the concept of the parameters, I believe. So, and then in our implementation of this .h file, we're going to implement the print method. Implement set undergrads, and then implement set postgrads. And what are we doing? Same thing we did in Java, actually. This is the postgrads up here, postgrads, and we're making it equal to. So in Java we'd do this, actually. Some of us would do this. this. In we're not going to get an error message because this is just in a text window. And if we wanted to do the equivalent Objective-C, we can go self. Self is the keyword instead of this. But we don't have to do this at all because we're not doing any inheritance and we're inside of the class object already. So, but we could preface it with, you know, where in the hierarchy for the same reason why we would use this essentially. And then we're just printing it. This is just going to do an NS log, so printing it out. If we looked at the main program that goes along with this one, it looks like this. And what does this do? It's like the main programs that we see in Java. Forget the memory stuff right now because we don't really need that. But we can say student, and then we could go this way if we wanted to. And we can put the point. We can put the asterisk here, or we can put it over here. It doesn't really matter. It's just basically indicating that this is going to be an object pointer. So student. And then once we use it here, we don't have to use it anywhere else. In C++, we have a reference and a dereference. In Objective-C, we have a reference. And then we just use it by its name. The dereference is already assumed. And we don't have to use the address of it either. It just finds it automatically for what it's supposed to be, which is a little bit easier. But if you're a C++ programmer, you don't like that because it breaks all the rules of C++. So. Alright, then we have the iOS student here, which is going to be equal to a student alloc, and then iOS. And then this is broken out purposely into two separate steps to show you. Usually you're going to see it in one step, but it's really two separate method calls that are being run, one to alloc and then one to init. Excuse me. And then here's how we're setting those parameters. We're applying the methods to the instances. So we have iOS student set undergrad, and then we're doing :120. And then here we've got set postgrad :2000, or something, yeah, 2000, with a space in between each one of them. It's kind of interesting that they lined up correctly in this example, but that's kind of coincidental. And then we're running the print method, and the print method is being run on the IO student, and IO student is this guy up here that we're using. And we don't have to drain the pool, and we don't have to release anymore either. So these lines of code would go away as well in our Xcode project if we were to create it in an Xcode, unless we deselect it. So if you get examples, anytime you see pool, drain, or you see release, and you want to use it, you want to test out the example, just make sure when you recreate the project, if you're going to do it that way, deselect auto-referencing, and it'll work just fine. And then if you accidentally create it and it's using auto-referencing, then just take those lines out. Take all of the releases, all of the retains, and all of the drains out of there. And then you're set, essentially. Okay. Let's take a look at a class example. The class example I want to look at, is it this one? No, it's not. This is the one here, the first one I showed you. I'll do that one. I think it's going to be number 3, actually. Number 3. Alright, so this one is another one of the downloaded examples from the Objective-C course. This one here, if we can get past the warning messages, has a class that we're defining. And let me make these windows a little bit, there we go. Make the window as big as possible so you can see what I'm talking about here. This is person.h. This is kind of like what I was trying last time, or creating last time, but this one has comments in here, so you can read through the comments, but it also basically is more functional as well, because it's, you know, complete, essentially. And what do we have here? So we're importing NSString and NSObject from Foundation. We could just say foundation.h here. So this is kind of the long way of doing it. But the import is used instead of the includes. And then we're inheriting from NSObject. And then the instance data is kept in here. We don't actually have to use the keyword private. And all of the examples after this, you're never going to see @private. This comes from like a public, private, and protected perspective. The @private is assumed if you leave it out. So the only reason why you'd put this here is for a teaching example. What you might want to change, however, is this. Here you can go public, which is a bad idea. because then you just exposed these data to the public. More so, just taking it out, it is automatically assumed to be private. So essentially, what the situation is you want to uphold object-oriented behaviors and design patterns and rules as much as possible, but you're allowed to break the rules. So it's very similar to like C++ actually, where you can program in the entire language without ever using any object orientation, but you're using an object-oriented language. So, but this is more on the protective mechanism of the class. If you expose the data members by making them public, you've ruined the integrity of the hierarchy, essentially, because anyone who wants to can change those data members into anything they want, which might be dangerous. Okay, here's our method declarations as we've seen before. The methods are defined by the return type, the description, or the name, the argument type, and then the argument name. So this is kind of a different syntax that we haven't seen yet in the examples coming up in the PowerPoints, but we have person with an asterisk because the object type is a person, and excuse me, the type person is an object, and the reference has to be included. So we have to put that asterisk in there because it's person. So just remember, anytime there's ever an object that you create, NS objects of any sort, always put the asterisk in there. And here's our initializer, init with name. So we're going to initialize the person with a name, and the name is going to be of type NS string, so we got that asterisk in there. And the string is going to be N. I guess I could have called the string name. And then here's the other thing. So we've called the second parameter and age. We could leave the and age out of there, but when we go ahead and run the method, we're going to know which one comes first, one goes second. So it's kind of natural to say, Barbara and age. So we'll see when we look at the main. It kind of makes for a little bit more intuitive init with name kind of call. But the name is coming in under N. The age is an integer value, so there's no asterisk in here, and it's going to be A. It's going to be represented by A in here. And these are the parameters that are coming in from the method call. So inside of the implementation, we're naturally going to assign name to N, and age is going to be equal to A. So, and the rest of this, we have integer age, which is basically going to return the age, get age. So we're using this format because when we use the properties in the synthesize, we could create a function, a method that says get age, set age. Or we could just say age. So when we say age, which is what we're going to do, if we use the properties and synthesize together, there's no gets or sets or anything because we don't write those things. So instead we say name, age, we just say the variable name, and it automatically runs either the setter or the getter associated with how we're using it. So we can say name set text to something, or initialize with string such and such or something. Okay, so these are the function prototypes. We have another one in here, speak. So in a string speak. So if we looked at the implementation for this, incomplete. Well, I've left out the implementation for speak, I bet. You know what's in there? I'm not sure what I've left out at this point, but it's okay. So here's our self. So in the beginning of all of our initializers, and this is the first example that I'm showing you that has an init. We could put another one in here that just said init if we wanted to. It would be the default initializer. It would not take on any parameters. This one's taking on parameters, actually 2 of them. So this probably should have said with name and age or something, but it's okay. It's not very descriptive. But, so the methods are called with the class and the method, as we've seen before. So init is the method provided by the NS object that provides the default constructor. So this is similar to in Java when we did this actually. Called self, or if you ran self, we're going to get an error message because it's not Java. You can't write Java code in ObjectiveC, but it's the equivalent to running. Excuse me, I'm sorry. Super is what I meant to write, not self. Originally, I started the day out writing C++, then I switched to Objective-C. Now I'm trying to write Java. Super! And we can send super, you know, parameters if we wanted to. If name and age was back in the super class. But that's not gonna That's not gonna work. Like running this. So we usually put super or this at the beginning of the constructor. This is equivalent to that. And self is going to equal to super init, which means you're now going to initialize with your super object and its objects in it. So you're now becoming an object, you know. So you're running this super class constructor. It'll return successful, continue the initialization. This is always the first line of the initializer, same way as super, and this was when you supered back to the original was the first line of the constructor. So you can do a check. If self, if we've returned successfully, we have ourselves, we were born successfully, then skip this stuff because we don't have to release anything. We never have to do this. We still have to do this though, but we don't have to release. So n retain because we want to keep n, but we're going to release name. We're going to release names. We're going to set name to equal to n. So it's because what do we need? In the old days, it was like, what do we need these parameters for? After, you know, it's like garbage collecting. What are we going to do with these parameters after we use them in this method? So this was manually telling the compiler to get rid of them, that don't reference them anymore. But now we don't. So this code here can come out completely. No need for that code in here. So I don't think I have auto-referencing on this project, so I'm gonna put them back in just to be sure. I can always download it again if I make too many typos. Here we're going to set the age to A, which is going to be the other parameter that we have in here. So we have pass by value. So it's not a pointer. So this item here, age, oops, if we go up here and look at age. Age is an integer, and a string is a pointer. When we take the pointer in on a parameter line, we have to garbage collect because we're doing dynamic allocation. There's no allocation done with that at all because it's just not a pointer, which is why here we don't have to do, in the old days we don't have to do the retain and the release, which are pointer, delete. It's equivalent to delete. Well, actually, n is retain, which means because we're going to have assign n, we could put names equal to n and then just release them both if we wanted to. Release gets rid of it. It says, okay, we're done with this. We don't need this anymore. So. And we released name to clear it out so we can add n to it. That's what we did actually. So name is equal to n. Okay, so self is now going to mess with this in C++ and Java. So return self. So constructor, nah. An initializer, okay. That returns. So in C++ there's no return type on constructors. In Java there's no return types, but in Objective-C we have return types, which is kind of interesting. But we're returning self. What else are you going to return? So now we're created. So here's the implementation for name. We're just going to return name. Age, return age. Speak. What are we doing for speak, actually? We're allocating a new string that's going to be called results. And it's going to say, hi, my name is such and such. And there's a lot of spaces in here for some reason. But it's going to say, hi, my name is, and then we have this at directive here that we saw before. My name is, well, what is my name? It's going to be name. And so we substitute in the first parameter. In fact, that's the kind of interesting thing. I had one time a student said, you know, can you put this in any order you want? No. So this is the first, and this is the second with the statement with the dollar sign. So if the dollar sign, excuse me, percent sign here corresponds to the first element, and then the second one that appears is this D. Well, you can use a D for digit or I. Actually, you can put I in there for integer. So either one of them is going to work. And then return. So return result. And result's this string that we created. So hopefully, after looking at more examples like this, you're starting to get, you know, repetition because it's all the same stuff we're doing. Unused variable pool. That's what's implemented is the pool. Okay, so that's okay. Instance method dot get age not found. That's okay. We don't have to worry about that. Anyway, because it'll run. These are just warnings. Usually when you see warnings like this, might actually lead to logic errors versus programming errors. So what I did here is I probably, well, I'm not garbage collecting correctly because I never released the pool. Because I have barb release, but I didn't release the pool. So I could put release pool down here, but this program is probably going to run anyway, just fine. It probably might crash if I run it like 10 times because I'm going to keep loading stuff up into memory, then loading more stuff into memory, and then loading more stuff into memory. And I'm not pulling anything out. Eventually I'm going to run out of memory. I'm going to have a bunch of garbage up there. So garbage collecting, by definition, is just getting rid of all the garbage that's out there. Alright, so what am I doing here? I'm doing it the old-fashioned way, so ignore this. The next example is going to be the current way. But this is creating the pool. And then I'm creating a name here. The name I'm just hard setting to barb. So, and then I could do a scanf and a printf actually to get the information from the user, and then print the information out. But I'm running the method here, string with string. So I'm assigning the string with a string. So NSString, string with string, barb, which is kind of interesting. And you have to use the @ directive actually to say that this is a string that we're going to assign. So then person pointer barb is equal to person alloc integer init with name. Well, what does that look like? Well, that's the initializer. So the initializer that we created, name and age. So the and age. So we always follow, because the initializer has a named parameter for the second parameter, we follow it with the name. If we leave this out here, we're going to get a message because actually, will it work actually? That's a good question. Not found. See, it's not found actually. So it's requiring that identification that's in there. So it's requiring it because it's defined in here with it. If I took it out of here, and I took it out of there, if I take it out of here and take it out of the implementation, it would work. We don't have to. We can, but that's hard to read. Actually, most people do this with it, but that's hard to read. It's a lot easier to see. Well, that's a second parameter. You know, that's a and age. So it's a name. It's a named parameter versus a generic unnamed parameter. So, all right. So if I go back to main here. And I'm seeing now, I decided I'm going to use printf instead of nslog. So printf, believe it or not, actually still works with the methods. It still works with objects. But I'm converting the object to a string. And I'm converting it using a UTF-8 string format, which is a C. It's a compatible format. So printf can't handle NS strings, so we use this format to return the character array out of it. Because we can't mix and match objects with non-objects in old style C. Because this is a C, iostream.h actually, library call from like C days. This is C programming in Objective-C. So we can't take an Objective-C method here that's going to return a string, an NS string, and return it in something. It's not backward compatible. So we convert it to something that is backward compatible, which is the character string. And this is the data type that converts this, that creates that data, that character string. So we're running this method on this output here. So this is like get name, barb get name from the name method to return the name. So this is going to return the name and then convert it to a string and run this method on this method, and then substitute it in for the %s. Or not percent. Alright, so if I run it, after I've made so many changes, it still works. Everything I removed was okay. So now we have name, barb, age 500, which is what this is doing here. Print name, age, and then print out the barb speak. And barb speak said something like name is this, age is that, kind of thing. So that's a kind of an interesting one. Let me show you one that's a little bit different. So that's number 3 out of, is that number 3? I think it was number 3 out of this one here, yeah. Okay, so we have the next one, which is going to be, it's going to be this one. I didn't open it up yet. Okay. do. Let's see. I'm looking for the car example. Let's just check this one out real quick. This one's person and employee. Actually, before, I have another one that does properties and synthesize, but I can show that to you in a different way as well. But here's inheritance for you. So we just saw the person class, and we just had a name and an age. So we still have the person class in here. So this one takes it a step further, actually. This one I called it set age and get age, just to be consistent with this. I can rewrite this class actually to use synthesize and property, which is essentially going to make these things for us. So this is a hybrid. So in the .h file, out here I've got, in fact I don't have to show you the cars now, I can just show you this way. So we have an at property and a string, and we're using an asterisk because it's a name. And then here I have set age and get names and get age. So instead of doing it that way, I can go here, property. Oops, property, and then I can go integer, and then I can go age. And if I spelled property correctly, I would get something that looked like this. Change my syntax correctly, there we go. Type in the right language. So, and then I could take this out up here. I don't need this up here anymore. And I don't need these guys anymore either, because the property and the synthesize, excuse me, the property and the synthesize is going to create these for me automatically. So I'm going to pull these guys out. And so I've got a property, a string, and a property and age. And then over here in the main, synthesize name, well, let me just synthesize age as well. And so now I don't need a set age and I don't need a get age either. The program should theoretically work the same as it did before. Maybe I should test it. Let's see what the program output actually looks like first. And main might be calling set and gets. Yes, it probably is. And I've got some automatic reference counting, grow sum, because I've got get age. Alright, so my main is designed to run those methods. So let's just run this here. Age. Fixed it. No more get age, no more get age, right? Is that the only error? Let's see. No. Growing results, 150 is the output actually. That's the only thing this program is actually doing. So let me look at main real quick so you can see what this is actually doing, and then I'll go through the inheritance part. So what is main doing? Main, here's main. Main's making a person object, object 1, and it's making an employee object, object 2, because employee is going to be inherited from person, inherits from person. And then it's going to set the age. Well, that's interesting that the set works. Oh, you know why? Because object 2, they have a set age, I bet, re-implemented. Which is probably the case. So anyway, we'll just leave that alone because it appears to be working actually. Then the printf, here we have a grow sum, which is a method run on employee. And then the only thing that's being printed out is the final results is going to be the grow sum, growing results, and it's going to be object number 2 with the grow sum method that I'll show you in a few minutes. But grow sum is going to take, I believe, grow sum, let me just take it for a few minutes here. Grow sum takes and returns 10 times self age. So whatever the self age was. These I believe are implemented in here. Set ID, grow sum. So alright, so let me go back. So in here we have person.h and it's the implementation, and we've used property to set 2 data members. We don't really have any member functions out here anyway, so in the .m we've imported the .h file. In the .h file we have :NSObject. So in the .h's, in the interfaces, we're always specifying which object we're inheriting from, and the implementation is just the complementary filling in all of the methods for us So all the real meat of the assignments of everything is in the .h file. And here we simplified it by going foundation.h instead of going NSObject and string and everything else that might be associated with any components. So in the .m, we're saying implementation person, and then we're synthesizing name and age. So we synthesize in the M, we have property in the H. So let's take a look at employee.h. Employee.h is going to import person.h. Because over here, instead of importing from, and I just put a little space in here to make it clear, you don't actually have to put a space in there. You can put this actually like this. And I think you need a space right here. Maybe you don't. But it's really hard to read it without the space. Before we had NSObject up here instead of person. And then we were not an inherited class. We have no hierarchy because NSObject is the highest object in the hierarchy. So if we're going to put person here, we're going to get an error message if we don't have this because we don't know what person is. So we include person to say, well, this is who we're inheriting from, and we put person here. And then in person we have name and age from, in employee we have inherited name and age from person, and we're going to add an ID, employee ID, to this property. So we also have a property here, and this is kind of, I'll just leave this alone, but I did it both ways. Usually you're going to go one route or the other. You're going to use property and synthesize, or you're going to do it this way and then create your own setters and getters. Here I kind of left out actually the get ID. There's no return ID method in here. So I could, if I wanted to, I could put it in there. And if I were returning an ID, it would be an integer. So I can go like this. Get ID. And then I'd have the function prototype for the get that corresponds with the set. So, but then I'd have to implement it too. So if I go into the employee, I would have to add, because it's going to say, now immediately I get this little thing that showed up that wasn't there before, because it's going to say incomplete implementation. It's really just a warning. If you don't want to implement it, don't implement it. It should theoretically run, but if you go and try and run get ID, you're going to get some really weird logic, because it's not going to return anything because there's no method body created for it. So in here, I've got no inheritance, but I'm still including person.h inside of employee .m is where I'm in right now. I'm in the implementation file. So I have employee.h and I've got person.h, which is kind of, what do you call it, redundant? I don't know, it's kind of silly actually. I think they have to include it twice. But if you don't, it's not going to recognize any of the person stuff. So it's like a scope thing, if anything. Okay, so implement employee, synthesize job title. What's job title? We had a property out here for job title. Here we go. Here's our job title. So synthesize it because we have a property on it. And then we have an initializer here. Lo and behold, we're just going to run init now. Instead, we're not going to run init like init with name, init with age. This is just a plain old init, which means this is going to override the init from super. So if we create a new employee and we run init, it's not going to run NSObjects init. It's going to run the init that's been overloaded. So it's going to run this one. But really, it's all this one's doing is running the supers. So this is pretty useless, actually, if you think about it. Because all this init is doing is running the super classes NSObjects init, which is super. So super is equal to super init. Why don't we just call init to begin with? And we just call back to the original NSObject init. We're not doing anything here. So you really want to do in here is I'd probably initialize job title to something. Or initialize name and age to something like you would use for a default constructor. Set it to 0, but we don't actually have to, because in ObjectiveC, if we have an integer and we've declared an integer, in this particular case age, it's automatically set to 0. And a string is not, it's a null string, there's nothing in the string, it's an empty string. which means we can declare and we don't have to initialize. So we automatically get initializing to whatever default values would be appropriate, like a blank string or something. So there's really no need to actually set it. Here we have a set ID method that we're running, and the set ID method is going to set the ID that's here from the synthesize. Or no, actually, where is it? Oh, it's from the ID that's in the .h file. And I'm just going to print out employee ID is equal to something or other. Well, this, I think this one failed, or maybe I didn't run it. I probably didn't run the set ID, so I didn't run everything in the main. So using the get age from the person, well, we're not going to use the get age from the person because get age doesn't exist anymore. Because remember, I turned it into a property instead of a set and a get. So it's going to increment the age. So here we got self age times 10. So I don't know what I set my age to, but let's see what we got. And this is basically all of the implementation actually that exists for this. So out in main, we have a person object of type person. So we could have said ID here, and then we could have, so, you know, instead of calling these could have been ID object 1, ID object 2 if we wanted to. But we're just going to, we know what object IDs are supposed to have, so we're not going to dynamically do it. We're just going to statically kind of set it. Person alloc, employee alloc. Well, person alloc is going to run the person. It's going to run the NS object because there's no initializer in there, I don't believe. And employee is going to run the employee's alloc. It's going to run the employee's init. I'm sorry, that's going to run the person alloc. Person init. Okay, so we're going to run the set age on both, which is interesting because we don't have a set age in there. I wonder if that one would work. Yeah, set age. We'll just go set age. Let's just leave that alone. I don't know, maybe I left it in there, I'm not sure, but. And then we have, because it is working actually. So, and then here we're on the object number 2, we're growing it. So we're running the grow sum method. So let's take a look at that real quick here. Well, we actually do have the setters and the getters for the ages, although we don't have it implemented. It is working. So. But the default, actually the default is, I'm confusing you as I'm rambling here. The default is set, so it's always set. But I thought I had age as a lowercase, which was why it was interesting to me. Yeah, age is lowercase. Huh. But when you have to, it follows the naming convention with the 2 words. So it automatically converts it to the set age with capital A. So which is kind of interesting actually because I pulled it out. So alright, so questions, comments, or concerns about inheritance. The only thing really different from Java and C++ is the syntax here. You know, instead of saying extends, we're going colon NS object, and persons going from NS object, and employees going from colon person. And we have the same rules as before. We include everything. We still can go super back to the previous constructors. We can override and we can overload those methods as well. So. Alright, that is one of the examples. Oops. I believe the second one is going to be the cars. No, it's the rectangle and the square. Well, this is why we're here. We'll just look at this one again as well. So here we have another program, and we run it to see what happens here. We can kind of see what we're looking at. It's another command line program. So these would actually run outside of Xcode as well. In fact, you can compile Coca window applications and documents outside of using the GCC compiler as well. You don't have to use Xcode for this at all. So. Well, I don't know why you would not want to use Xcode though, because Xcode automates it, makes it a little bit easier. So we have a rectangle, a square, after changing, and then we have the height. Yeah, I don't know. Oh, it's word wrapping is what this is doing. So here we go. So we have 3 objects that we created. We created 2 objects, a rectangle and a square, and then we modified the square. So essentially. Okay, so the square is from the rectangle. So we'll start with the rectangle. The rectangle, we have the .h file here. Let me get rid of this. So this is a little cleaner looking, actually. So what do we have here? Interface rectangle colon NSObject. Well, that means it's the base class. It's the root class that's inheriting from NSObject. Property non, well, I'm going to skip non-atomic for right now. But the syntax is always at property, and then the data, we can put weak, we can put strong in here, and we can put different things to tell the automatic reference counter certain things that we want to change about the default behavior. And I'll talk about that in another lecture. But integer width and integer height, which is going to define our rectangle height and width. And then we have an initializer here that's going to initialize one with a height and the width. So we have, this makes a lot of sense here because we say width something, and then we're going to go height something. So we know which one's the width and which one's the height when we pass the arguments. Otherwise, we just pass two numbers. We don't know which order we're putting them in. A set width and then a print. So the set width is going to actually, so just because we've done this doesn't mean we can't do a set and a get. We can always implement our own. So this is going to be a set width, and it's not going to be the default one because we're going to set it with, so we're going to set it with a width and a height. So we're going to set the width and we're going to set the height all in one shot. Okay, so if we look at the implementation for it, the .m file, this is the interesting part here. We've synthesized with a rename, and we renamed with, because we're using things like height and width, which can be kind of generic terms, and I just showed the other class this, the ObjectiveC class this earlier today. And we can go width is equal to, and then we have synthesized, and then we have also renamed at the same time. So every time we refer to width, we use the underscore in front of it, which means it's a variable, or it's an item that in this particular case, it's not like a keyword, it's a variable, which is, you don't actually have to do that. You can pull that out and just refer to it as width and height, but it might be a little confusing after a while. So rectangle asterisk because it's an object type, and this is the implementation. Well, what's the implementation going to do? This is a little bit better. This is a better initializer because this one's actually doing something. Rather than, if you're just going to call super, if you're just going to have this line of code in there, you're not really doing anything. Here you have a full implementation. So if self set width, set the height, essentially, which is essentially going to be, you're going to run this method inside of the initializer. Boy, we're slowly going down in numbers here. I'm like, what is it, my lecture, or is it the bus schedule? It's the bus schedule, I know. I'm not taking it personally. I know, I'm never having these late classes again. Okay, so back to this. We're running the method set width to w set height. So we're setting the height and the width inside of the initializer by running the method that we've actually defined in here. And here's the method here. The method that it's very common. You'll see this in Java and C++ as well, to run methods that you've already created inside of the constructors. And then this is just saying, and this is very Java-like as well. We can leave out the self.width, the self.height, but look at that. We're not using the as, so we're not using the underscore here. So when we're doing the setters and the getters and we're working with the variables in terms of what they are, we're going to use this guy, this notation here. This is self-width. Well, we have a width. Well, where's the width? The width is here. Width, height. We're actually setting the variables from like the variable initialization and not the alias that we've created for it. So we've created the alias here that we can use to reference this, essentially. Give me the width, give me the height, kind of thing. If we are going to use we're going to use the reference with the self. So self.width, self.height. It's going to show up here. And when we print this out, actually. And we can print it out natively because these are both integers. So we don't have to convert an object into into a character array or into something that a primitive print function could actually interpret. So this is kind of an interesting example because of some of the aliasing and some of the nested methods inside of initializers. Okay, so if we look at the square, and we go to square.h, we know that square colon rectangle. So our square is a rectangle, so we have rectangle in the include here. And then square is the data type. And initialize with size. And the size is going to be s. Because, you know, the height and the width are the same, you know, so s, that's the size. That's how big it is. 5 whatever, integers. So we have set size and size, which is our primitive way of creating the essential methods that we're going to use for here. And then I'm going to go back to the .m file so we can see the implementation. The implementation for square. We have init with size, which is our method for our initializer. And we're going to run the set size, same as before. Actually, down here, set size is going to be self.width is equal to s, self.height is equal to s. So instead of specifying a height and a width, we're just specifying s. And it's the same for both of them because it's a square. And then here's size. The method's just going to return the size. So a lot of extra coding we don't actually have to do. If we used property and synthesize, we wouldn't have had to done any of that, sets and gets. But, and if we look at main, what's main doing here? So main's pretty trivial. We actually have to import both the square and the rectangle because we're going to use both instances in here. Rectangle because it's an object. We're using an object reference type, so we put the asterisk in here. So rectangle rec is equal to rectangle alloc, and then run the initializer. And the initializer is running, this is word wrapping, but the initializer is running init with width 10, height 20. And then the square, well, square is a type of rectangle. And now we have SQ, so we have square alloc. And then we're running init with size, the initializer for that, so it's 15. Because it's only S that the initializer is taking in for a square. Although it's a rectangle. So it's passing back the S, and it's going to be initializing the width and the height to both S. So we print the name, rectangle, or rectangle print. We have a print method in there that's just doing a printf, essentially. Print the square, square, print square, update the square. Square set the width to 20. So the square after the update, we're going to see it's at 20. So we ran a set width on the square when the square, let's go back to the square, has a nothing. We just ran a method that was a rectangle method on a square because the square is a rectangle. So the example is basically showing you, we didn't set a width, we just set a size. We didn't set a height or a width, but we got a width set because it took S as the initializer with the size, and it passed the S back up and it made it equal to the height and the width. So it assigned those values automatically in terms of the implementation. So by running the initializer. So if we run it, we get the output that you might expect. We saw before. I don't know, it's just another drill to kind of show you how to use the inheritance and the initializers. So the initializers pretty much did everything for us, which probably how things should work actually. So. Okay, that was number 2. Just see if I had anything left. The protocol is kind of interesting. I want to do protocols. Today, do I want to do protocols? No, let me wait on the protocol, actually. Let me wait on the protocol, because that one is... so can you remind me, we're doing... Here, actually, you know what I'll do is I'll pull it out. Put it on my desktop, and I'll get rid of this one here, so I know... my desktop is slowly getting cluttered. I'm getting rid of the ones we just went through. Alright. And I believe we just went through this. Let's see. Just want to make sure this is the... Yeah. Okay, so now we're ready to continue a little bit further in the lecture until we run out of time today. Oops. Okay, so the examples are worth looking at if you are interested in actually implementing this. It works the same way in an iPhone, iPad, or in a Coca application. Okay, so I can skip some of this stuff because we already actually kind of went through. I just, instead of showing you the PowerPoints, I actually just went through it with examples instead, but just make sure I didn't miss anything. We have our GCC, our framework. We learned about the NSString and how that's being used. And the constant, it's actually called a directive, but it's the NSString is a constant value. It's preceded by that @ symbol to tell the compiler, to direct the compiler to create that constant symbol. So some people call it a constant symbol. I call it a directive because it's a compiler directive. But you'll hear it being called several different things. We don't have to worry about this. I've already showed you the NS auto release pool, the newer way of doing it, so we don't have to drain the pool. And this is essentially going through the example 2 that I went through. So. No line breaks needed at the end of the NS statement as well. It automatically puts it in. Excuse me, NS log puts a line break at the end. NS string constants use the C style variables, and the test program example number 2 shows you that results. So in terms of the interface, it's equivalent to a C-class declaration that would actually go into a .h file if we were doing this in C. Functions are outside of the curly brackets, as we've seen before, and don't forget the end tag at the end. So the NS object, as we've seen, is the root object, and that there's no direct access to instance variables. So we write the sets and the gets for the instance variables, because there's no direct access because they're declared as private, actually. And then we have instance methods that affect the internal state of the class, not outside of the class, preceded by the minus sign. And the class methods, we'll see those with the protocols actually, but I'm going to wait till Monday before we do that. They're higher level functions. They work outside of the class concept. They're actually more like just functions, like in the class methods are functions actually. Really the traditional style function in a non-object oriented world. They preceded by a plus sign, and they create new class methods. They're created with the class methods. So. And the method return types are always in parentheses in terms of the declarations, and we have a semicolon before the list of parameters. The parameter type, actually that should be a colon, not a semicolon before the list of parameters. Parameter type is parenthesized, followed by the name. So this is essentially the colon, not the semicolon. So that slide was actually wrong. Parameter lists are separated by colons. Semicolons go at the end of the lines, like in other languages. So the prefix of the minus sign, very similar to C, actually. Syntax is very similar to C in this particular case. We also looked at applying the methods for the instances in the format of the receiver message in those examples with the semicolon for variables or values passed to methods. Well, put a colon in there. Built-in messages use the alloc, init, and release. We're not going to ever use release, but alloc and init are still built-in methods actually. So whether we have an init or not, we still use it. And we still need to do the alloc, even with automatic reference counting, or ARC. So alloc is equivalent to the new, but it also zeroes all the variables as well. That's where we get those integers that turn into zeros, or strings that turn into something, but they're not like populated. Init should be applied to the instances before they're used. These are often combined together, as we've seen before, and this is our iOS student example where we saw student alloc with init. So there's no garbage collection on the iPhone, so we have to release all of the instance memory ourselves, unless we're using automatic reference counting. We looked at example number 3 already, and if you run the one that's in the lecture set, make sure not to turn on automatic reference counting as an example. So let's take a look at data structures. And somebody tell me when it is, let me just take a quick look here. Okay, someone tell me when it is 8:45. Is that okay? Yeah. Because I don't want to go any later than that. So, I know it's like around 8:16 already, so about 20 minutes or so. Okay, good. Data structures, because I can get carried away with this, that's why. Objective-C arrays are very similar to C arrays. Okay, so we have arrays, and hopefully you're familiar with that. They're the same as Java arrays. They can be initialized as a whole array in a list, or they can be done separately. or just a few of them one at a time, and then the rest are set to 0. Or you can mix and match. These, the same tricks that are available in C, in terms of arrays, are available in Objective-C. None of them are available actually in Java. Well, small percentage of those tricks are available in Java. Here's examples of what I'm talking about. So initialize the values, 3 indices, or 1, 2, 3. That's the traditional style of doing it. Character letter 3. We have 1, 2, 3 is another kind of way of doing it. Well, here's a different one where we said float grades 100, but we're only initializing 3. And the rest of them are all zeros now. So, and then this way here, which is kind of interesting, where we've got, and you can't do this one in, I can't do this one in Java. Where you have integer array, and then you have 3 is 11, 2 is 1, and 7 is 0. So that's a pretty good shortcut. Actually comes in handy for a lot of different things. But you're not doing all of them. And then all the rest of them are 0. Everything else that you did not initialize is going to be 0 automatically. Yes. So it's like taking array 3, array 2, array 7. Very similar to doing it this way. This actually will automatically assign this value as well to 3. Actually, it's 0, 1, 2, but it's 3 items. So this array size is 3. Yeah. The array indices goes 0, 1, 2, and this is array index 3, 2, and 7. Well, then this is going to be more than 7. This is going to be more than 3 if we're assigning 7. If you assign it a bit, if I left this 3 out right here, this would actually turn into values 3. So, because I didn't specify the size here, this is going to be 7 actually, because this is going to be the highest one we're setting, and everything else is going to be set to 0. It automatically assigns the size that's needed for memory storage, given the indexes that you've given it, the values.
Is that only works when first initializes?
Yeah, when no, you can't. We have mutable arrays actually in Objective-C, but they're objects. They're not variables. The objects take care of a lot of the problems with arrays actually, because arrays are statically allocated, but Objective-C is dynamic. So the implementation of the array is still done with pointers, and you can grow an Objective-C array, but you can't grow a regular array. But an object can mute though, but non-objects are stuck because they're static. Variables like integers and floats, they're predefined at compile time what they are. So unless you make your own implementation of an integer or float, it's the same as an array, and then you can kind of adjust it all you want. Multidimensional arrays. So you can initialize by using subset notation, brackets, as we've seen here. No comma after the second subset. Nope, second one doesn't have a comma because it's the end of the list. And then the subset brackets are identical. The compiler will fill in the blanks where it can with the one dimension. So it goes rows and columns. These are the rows, these are the columns. And here we're just setting the rows, we're not setting the columns. So it'll fill in. It'll fill in where with the one-dimensional arrays. Arrays and functions. So arrays can be passed as arguments to functions just like they can in C. The function will print every integer in an array, but it needs to also know how big the array is. So we always send it the array length. Same thing you get in C actually. When you send the array, you always have to send the size. Otherwise you can't tell how big it is unless you use the object version of it, and then you can. So statements with hard-coded indices such as array 4 are potentially dangerous. Actually, this is potentially dangerous because how do we know we have 4 of them in there? We may only have 1. We may only have 2. So.
Isn't that just assigned value of 4 in there?
It's fourth indice or the. It's like the size. If you hard set it, like this particular case, we're assuming that this number is bigger than 4, or at least 4.
So is this something like a try and catch like Java does?
No, that's why it's dangerous.
If it fails, then it would just completely stop.
No, actually, arrays are kind of funny. In fact, if you do this, it's not a bad test actually. If you do it in like C.
Or just some funny memory allocation. notation.
Yep, it'll get some weird piece of garbage. It'll be like, what's this number here? And it's like a smiley face and an asterisk and a something else, you know, and you're like, what is that? Well, that's like the ASCII representation of some weird code that was stuck at some memory address that came out because you wrote past the bounds of the array or you read past the bounds of the array, which is kind of interesting. There's no error checking on arrays in C. There never was. And there's not error checking in Objective-C either. But we have implemented dynamic arrays that we can do as objects. In fact, Java's got dynamic arrays as well. So the good old structure. And the union is actually compatible with Objective-C as well. So the structure was like the pre-class. In the structure, you can actually use the dot notation with it, which is kind of interesting. So similar to the Objective-C structure, it can be initialized in one go. So you can create the structure and make an instance of the structure altogether. Use the dot member notation, or you can just use the values in the correct order that you want to use. And to follow the example, we're going to define the last member, but the others are undefined. So here we go. Structure student, and integer BS years, PhD years, and then well-spent years. So we have 3 integers that are part of the structure. You guys have seen structures before, right? In C? Okay. It's the same concept. This is the C structure. Supported. So sometimes people actually, there's a really good reason why structures are lightweight. There's no .h and no .m that goes along with it. It's not like a full class, and it's not an object. It's never a reference either, and you can use the dot notation. So a lot of C programmers who transition into Objective-C really like structure. I like structures because they're kind of easy to work with. They're familiar territory at the beginning, but then eventually you go away and you don't use those anymore because there's other ways of doing it. But structure student, well, here's another declaration of a structure where we have structure student, my career. Okay, it's going to be equal to dot BS years is 3, dot PhD years is 3, dot well spent years is 6. Okay, then we have structure student poor life decisions with no names, just the values that are inserted. Where we have structure student unknown with just one value set, the rest of them are going to be 0. Or then we have some of them set, some of them not set. So dot well spent years is going to be equal to 0. And furthermore, so yeah, I don't know who really uses these other. I would probably go the traditional route on it versus the shortcut routes, but. Declaring and defining all in one shot. This is a structure for coffee order, and you have 2 integers inside of it, and at the end you're declaring an instance of coffee order. So 2? Yeah, there's 2. I thought I was saying 3 for a minute there. Complexity group, which is equal to 7, 4. That would be 7 for plain and 4 for double espresso in terms of the assignment of those values. So it's very similar to the old style C style notation. So it's definitely something comes in handy when you want to create something without actually having to go to work to create a class. In C, you can put methods inside of here too. So you have data members and methods. They're very similar to classes, but you can't inherit a structure from a structure. But you can nest a structure inside of a structure, which is kind of cool. And that the flip side of this one is also available, the union. So the union has one variable. So if I were to replace the word structure and put union in here, I can have one of these at one time. It conserves memory. So in terms of Objective-C, which is already managed for you, there's really no memory to conserve. So people would just go with a structure. But if you're worried about memory, the union would have to solve that problem for you. Because you're not allocating 3, you're only allocating 1. And it creates a polymorphic structure, essentially. We have different size fields and bytes that we can use as well, so it can fit into limited memory. Well, if you're looking at a small device, which is kind of ironic, so in the beginning of development for mobile devices, we were looking at what, like a megabyte? I don't know. We were looking at a very small amount of memory on those. Now that some of these phones have more RAM on them, 16, 32, then gigabytes than we had on computers. So are we really concerned about memory these days? No, I don't know. Well, RAM is still low. So storage space, SD card space is pretty big. RAM is actually pretty big too. In fact,
I think the latest one, the Samsung Galaxy X,
it's like 2 gigs or something.
it's like 1.5 gigahertz processor.
Oh, jeez.
So it's like better than netbook.
And then better than a netbook.
Yeah. you know the netbook with the Verizon that push it out.
Yeah.
You buy a plan to get this mini computer you can use.
Yeah.
It's like better than those.
Yeah. That's the new Galaxy. Yeah. No, I saw it.
Still want the Apple fighting for.
Yeah, they're suing them because of the concept.
Yeah. Now Samsung's shooting back. So they kind of like.
Apple can't take control over that concept. It's the smartphone. But you know what, though? I saw a picture of it. Actually, it's in the stores now, too, I think. I saw a picture of it somewhere. It looks like an iPhone. That's what the problem is.
Yeah.
If they didn't make it look so good.
It's almost like Apple. It have one button.
Yeah.
It's the home button, but it's the same thing at the bottom.
Yeah.
That one go back to the home screen.
It looks like an iPhone.
It's smaller.
It's actually smaller. It's Android, yeah. It's an Android-based iPhone. Looks just like an iPhone. It's nice, actually.
It is. They're catching up.
Yeah. Samsung. Yeah. Well, I think that's probably going to be taken off the market soon, though. So, I don't know. Get it now while it's available.
So
They're going like hotcakes.
As you do on YouTube, they buy it from like Europe and send it
Yeah.
and you use it.
Well, you can get them unlocked from overseas. Yeah. Okie dokie. So then we're getting back to actually this was a relevant conversation because it was related to memory. So we have bit filled, so we can work with devices with a small little memory. Well, we don't really have this problem anymore. So we still want to look at stuff. So here's unsigned integers can be used, signed integers can be used, small bits can be used, bytes can be used instead of full integers or something. So. The union is an example of another way, but we don't really need to use a union. But if we wanted to conserve the memory, we could. So a union also allows ambiguity. So it's kind of the predecessor to polymorphism. So because you can take a union, call it weight, and you can put an integer, a double, a byte, or something like that inside of it. So you can have pounds, tons. You can have partial weights or full weights depending upon what the user wants to assign to it. It can only hold one value at any one moment of time. So it's actually referred to as a record type. It was actually kind of one of the first record data types that existed was a structure in the union. So if you're familiar with the concept of the record, it's kind of like the database record. It's like the row in a database table, which is kind of similar to what a structure really is. Because for example, you have a structure student. A student can have a first name, last name, date of birth, all this stuff associated with them. It's kind of like a row in a database table. It's a record. So each student, and you create instances of variables, variable initializations of that data type, and then each person that you create has a first name, a last name. And so it was basically a way of storing complex data. Multiple pieces of complex data all under one name instead of having like 16 different variables. You have like one and it has all of that stuff inside of it. So it kind of revolutionized the concept back in the day and became it was basically the foundation for the class concept. And so towards the end people were writing structures with methods inside of it. So you can run a method, a function essentially, on a structure. You can nest a structure inside of a structure. It was actually kind of very feature-rich. So you just can't inherit. It doesn't use any of the inheritance stuff as a class does. So here's a basic concept of fitting a union, using a union for character, letter, and a float value inside of one of the following. Well, doesn't make any sense. I think a weight type actually would make more sense. So you have weight in tons, weight in pounds, weight in ounces or something. And use doubles and floats and stuff. So memory management. So we've seen the alloc. We know about that, or actually we already know about memory. So memory management Objective-C is semi-automatic. So we've seen this already. The programmer must allocate, 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 never has to deallocate. So explicitly allocate or indirectly use constructors. So you can create and allocate all your methods, or you can actually allocate, all your objects. Or you can actually just do the old traditional style format and then use alloc in your initializers. And in your initializer, you create the memory for the object. That way you don't have to call it out in main. No need to deallocate ever. So in terms of our allocation, here's actually kind of an interesting comparison. So allocation happens along with the class method alloc. The message alloc is sent to the class with the requested object. Alloc is inherited from NSObject. So every alloc creates a new instance, which is equal to an object. So hello world alloc, that's what we've seen. So the class creates an object with zeros in it and returns a pointer to it. So here we have hello world p is equal to hello world alloc, which we've seen already. Pointer p now points to the new instance. We can send a new instance through p. So here's that reference counter, what that actually means. So every instance that has a so-called reference counter to it counts how many references are retaining the object. So this is a reference to the object, hello world reference p. So p is a reference, we have one. We created the first one when we assigned it to p. Sending a retain message to the object increases the reference counter by 1. It says retain it, which means keep it, because we don't want it to be 0, because we're going to decrement it every time a reference dereferences it. It goes out of scope. So sending a release, or sending a release. So when we leave a method call that uses the reference object, we call release in the old days before automatic reference counting came around, and that decremented it. So it decreased it by 1. So we increase it by 1, decrease it by 1, and then eventually if we're hit 0, we clean it up. We don't have to do anything. It's going to be cleaned up for us automatically. So that's why it's kind of like semi-automatic. It's still sort of semi-automatic, but now we're just creating an auto-release pool, letting the compiler do everything. So there's no more releases or retains. But we still use alloc, which is interesting. You figure if you're going to automate the system, maybe the next release that comes out will remove alloc out of there, and then maybe they'll change the syntax so it's more like Java. Just kidding, I don't know. So reference counter equals the retain counter. So when the reference counter reaches 0, the object is automatically deallocated. Programmer just never deallocates anything. Programmer only does alloc or retain and release. If you're not using automatic reference counting, you're using the retain and release. If you're working with the GCC compiler and you're not using Xcode, then you're retaining and releasing. So those people who fight with Mac and they say, I want to run Ubuntu, and I'm going to put GNU setup on Ubuntu, and I'm going to run it that way. Well, you don't have any automatic reference counting. That's an Xcode feature. So you're going to be using retain, release, everything. Auto release pool. It's the harder way of going, I think. So if you're using Xcode, you're going to click that little button and you're going to let the Xcode do it for you. So, okay, so the method that does an alloc or a retain also needs to do a release. It must maintain a balance. So alloc or retain and release work in combinations. So if the method does an alloc and returns a pointer to the created object, then the method must do an auto release instead of a release. So if we have a pointer through an alloc, we do an auto release. So that's why we do auto release pool, or we do auto release. Calling the code can do a retain release, but it's not a must. In fact, if you auto release, it will do both for you automatically. So here's our auto release pool and what those statements were actually meaning. You don't have to do this one. This is if you don't have Xcode, or the current version of Xcode. If you have a previous version of Xcode, you're doing this the old way. Everything outside of the last version, you're doing it the old way. So for that release to work, programmer must have to actually create the auto release pool. And we've seen this before. This is the reference object pool. It's of type auto release. We're allocating it, we're initializing it, and then we're doing pool drain or pool release at the end. Pool release is the one here that's going to go with the pool. So Coca is used when the auto release when the auto release pool is created automatically. You don't need to actually do it. So and release the pool and all of the objects in it when you release it. So we know about the constructors as well as through the examples I showed you. This is the class method that allocates, initializes an object. The programmer is neither doing an alloc or an init if we use the constructor. So we can actually do this automatically, and here's an example of it. The examples I showed you today did the alloc and the init inside of main. We don't have to actually do it. How many times do you do that in main? You write the class once and you do it over and over and over and over again. So sometimes you see it without using alloc or init, actually. So you put it in a constructor, you just call the constructor. So here's a constructor. So the programmer neither is doing an alloc or an init. So this is a plus here. It's a class outside of the instance of the object that's creating an instance of the object for us. So you can't put it in the object if you're creating an instance of the object outside of the object. So instead of putting it in a main, you put it in a class and you call the function from a class. And the class is a method that's outside of all of the other things. So it's almost like putting it in main, but you're not putting it in main because you can include it. You can include this constructor. So you're basically making a constructor that's doing an initializing for you. It's not an automatic technique, it's something you actually have to program in. So here's a constructor with student with name, takes on a string name and a GPA. And then inside it's running self, alloc, initialize student name, GPA, return, instance, auto release. So it's doing the allocation for you. And then after it allocates it, releases it, sends it back to main so you can run it. So the method sends alloc to self, which is the student class object. And the method auto releases the instance because it returns a pointer to the created instance. So then it can automatically release it. Not essential, the example uses an existing initializer. It could use something else, or it can initialize this student data directly inside of the student method. So it's doing it outside. So when we call the constructor, this is how we would do it. We say ID student is equal to student, student with name, Johnny, and GPA 3.5. This is in the main program, by the way. So in main, you're doing this. And this is where I'm going to stop for today because I'm going to go too far into it. But this is cleaner looking in main because it's hidden. It's in this class method over here. We're using a plus symbol because it's not in that student object. It's in another object, and or it's out somewhere else in a protocol or something. And we look at that and we go, oh, it looks easier. No alloc, no init. So sometimes you'll see code that's designed this way because they're utilizing a constructor. Because shouldn't the constructor make the instance of the object in theory? So, but in Objective-C we have initializers and constructors, but the constructors are man-made or programmer-made in a sense. So the message is sent to the student class object and returns a pointer to it, and then the pointer is assigned to student. And then calling the code does neither an alloc nor an init when we call it. And the auto release pool must be in place. Well, because it's in here, it has to be in place in here. In the new instance auto release. So. Okay, someone remind me I stopped here. Because then I'm going to get into the GUI, the fun stuff after that. We'll talk about other stuff. We're almost done with this actually. So I have, oh, it's good timing too. I have protocols to talk about and a few other little things to talk about, and then we're going to zip back into iPhone examples and stuff that actually have more functionality to them, that create instances of objects and use those instances to actually create some functionality within the program. So that's enough for tonight.
Yes. So at this point,
yeah?
how far on the assignment we can go?
Good question, actually. You could probably get through all of them at this point because the assignments for this particular course, I think I have them downloaded already. Actually, I do. So this is an example of project number 1. And
Number 1 is the calculator.
I showed you actually an example of the calculator program. A simple calculator program.
Some.
Actually, you know what? Remind me. I have a start of this assignment actually. I'll put this one right here next to protocols. So number one is the start of a calculator. I can actually show you that one. It's really easy, actually. Tic-tac-toe is a little bit, the logic of it's a little bit, you don't actually, for none of these do you really actually have to do any object-oriented programming for it. This is all event-driven GUI behavior, so is the calculator. In fact, yep. And then this one here is a functioning clock. It's a bunch of buttons. All of these programs don't require any programming skill, actually. This one here is going to be the clock part 2 with the alarm on it. This one might require a little bit of programming. Number 4 is going to require a little bit of logic programming there. Number 5, let's just take a look at this one real quick. This one is easy, but we did it actually on the first day of class or second day of class. Let me show you this calculator here, actually, that I will try to remember. Well, I'm going to enhance it a little bit for next time. But it's this is not an iPhone. This is a Coca application. Watch this. I was building it earlier in the ObjectiveC course, but it's not actually dealing with any objects or anything. It's just event-driven behavior. So, example, you click this, and this up here changes. So I've clicked the 2, and I've clicked the 1. And I'm clicking plus, and I'm going sum, and I get 3 up here. So the clear doesn't work yet. But if I go 1, 2, 3, 4, this is going to change to 10, which is 4 plus 3 plus 2 plus 1. So it's just keeping track of which buttons I've pressed. That's and just see the code for this. This is not done. This is done in a Coca application, but you can actually do the same thing. It's the same thing, actually, for an iPhone application. All we've done over here, this is the appdelegate.m, which has got the IB action in here. We have IB outlets and IB actions. Same concept, actually. And we're just taking and setting variables to, values.
The blue calculator, like you type in the 1, 2, become 12.
Yeah, you can do that. Like times, 1 times 1, 2 times. That would actually be kind of easy to do. Yeah. All you're doing is capturing the event of the button and saving it in some variable, and taking the variable and applying whatever math. So you can do it. So this is actually doing it in reverse order. So you put the numbers in first. It's not doing it prefix, it's postfix. So you're going 1, 2, and then sum, or 1, 2 minus. But minus isn't working yet. Subtract's not. Actually, it's only adding right now. But I demoed it for another reason, actually. It wasn't, oops, I'm still recording. Let me pull this off, too.